My name is Pierre Renault, Vice President at SNC Lavalin. In charge of a group of about 155 people specialized in electrical mechanics in the Montreal area. So I have my colleague here, LaPierre, who is a BIM specialist who works with the SNC Lavalin TI group to do modeling and to use BIM on the project of the QSIM, among others. So what we'll be presenting today is the experience that we've had in realizing this project, this ongoing project, and maybe share with you some of the problems and issues that we are facing in converting, in fact, from the use of AutoCAD 2D to the use of Revit as a software, and also the modeling tools. So the first thing maybe might be to introduce SNC Lavalin. I don't want to introduce the company as a whole. It's an engineering firm, construction firm that does operation maintenance and funding of its projects. Except that in the group that I represent today, it's more the transport group, transport infrastructures and buildings. It's about 1,300 employees, most in Quebec 1,100. And we are specialized more in the engineering side of things that deal with buildings. And it's also our group who works with the BIM software. We've got another division within SNC Lavalin that uses modeling, not necessarily in buildings, more in processes and other software that are used as well. So just to explain a little bit in consulting, engineering, pretty much what it is that we are experiencing. So the group, in fact, of TIB represents about 150 people in structure and electronic engineering. We have conventional projects with offers, call for bids, and so on. But we also participate in PPP, including project we're going to introduce today. And we also have turnkey projects, international projects. We also have local projects. This shows you some of the offices of the division. Mostly, well, our headquarters in Montreal, of course. And most of our resources are in Montreal. However, we've acquired other offices recently, which gives us a little more spread of offices throughout the province. I would say that they're not offices with regards to engineering and structure engineering and so on. That it's mostly in Montreal and Quebec City, Toronto, and Halifax that these are held. The McGill University health project is a colossal project, really. It's we found the corner of Highway 15, and where you can see about 5 cranes, 2.2 billion square feet, excluding parking lots. So it's a product that was done in a public-private partnership format. It is, if we look with regards to the deadlines, we had a deadline in 2009. We handed in our proposal. In order to do that, we had to do the preliminary documents. We worked in AutoCAD 2D exclusively for that level because we were not, our organization, and I hear of processes and all that, but we weren't really aligned for that any other way. So in 2010, we received the contract, beginning of the works, and we plan to complete by fall 2012, service entry date, winter 2014, project delivery September 2014. It's a rather fast-track project, given that when we had the contract, we're already late, because we had to lay the foundations, and my colleagues in structure had to suffer a little. But if we look at the project, in fact, to give you a bit of an idea of the scope, because we use BIM And within this, we have to complete this project in design with BIM and Revit first. So there is a hospital for adults, hospital for children, there's a research block, there is right on the far right, there's another children's hospital, which is an added a project that was added at the end that is also done. So, in fact, SNC Lavalin does construction as well, and we also have subcontractors, consultants in architecture and engineering participate with us. So if we look at the preparations, I must tell you that before 2009, the use of BIM and Revit were not in our daily practice. In the past, we had mechanics rooms. We used what I think was building system. We had people in our teams who would help us to do certain 3D modeling for demonstration purposes often, but it wasn't really part of our current practices or regular practices. When we started to bid on the project in 2009, I must tell you that we saw this project and we could see the mountain in front of us because our designers did not know the software and did not have any experience. I must tell you that it's more true in electrical or mechanical electricity. But for the structure, I think some people had already started using it. I think the software, if I look, it's our perception anyway, within the industry, we feel that in architecture, it has evolved a fair bit. There are many companies, architectural firms, who have made the transition. And so the new projects, including greenfield projects, for totally new constructions, we have many architects who want to use BIM. And we also are participating as much as we can, do so with our resource availability. But in fact, it's not a problem of the quantity of resource, it's a problem more of having the qualified resource and experimented resource to realize a project. So therein lies a challenge. Now, as I was saying, at the level of structure, it started mostly in 2009. And what we did a few projects. And there was you who had initially said to master the software well. So that's what we did. We hadn't opened up yet. The opening was done through the QSIM project, and we saw that it was a rather difficult launch for us in terms of using it. But the difficulty is that when you want to put people onto this, it's not always easy in a context with regards to the work. It's a context where there's a lot of work on the market, and to be able to dedicate people, your champions, or those who are very good in this, is a real challenge. So it's a bit, I'm repeating myself, but since 2009 we created some teams, and people also from Haiti who have helped us to get organized. And my colleague will tell you a little more about how we got structured to do this. If we look at the realization challenges in electromechanics, one of the problems that we had initially was the maturity of the modules. I can tell you that in the electrical mechanics, there was a recent update of the use of that module on Revit, which greatly helped. But we faced many problems of use. There were bugs. Well, we had bugs, in fact, but all of that was fairly difficult in order to be able to start. Now, on structure, well, the use, I would say, if I speak to my colleagues, for example, where we have now a call for offers, we want to make projects in Revit for other projects. And usually in structural, I would say that the transition is fairly feasible. I'm not going to tell you they're going to use all the modeling tools or simulation tools. I think there's still a lot of work to be done in that area. But simply to use the software and realize a project of that scope, I think in structure it can be done. In electromechanic, uh, and I'm telling you, I think it's rather fantastic, the presentations that preceded me, because it shows that there's really, you're experts in your field and you are at the forefront of the market. And I find that wonderful. But we have a desire to change, we have the will to go forward. However, the market at present, and we try to find resources, people who are familiar with these tools, there's not that many of them. So it's rather difficult. So the training of the staff, of course, that is an issue and an important one. User profiles, one of the points that we thought about when we started using Revit, we said, fine, it's a drawing done in 3D. So for us, it was like a transition of our designers or draftspeople who would go from change of tools simply, and there are a few of them. Yeah, there's some very good draftspeople, very good with the tool, who had a skill and knowledge and experience sufficient to make that transition and to make do fairly well. But one of the big problems is that we're working on a problem that is very complex, with operating rooms, it's a big scope project done on a fast track. So we needed the best designers possible, and our designer in the electromechanics does, who are over 40, are less familiar. First of all, they don't draw necessarily on AutoCAD, so they're less familiar with that technology. And the young of 25 and less and under are come from a different generation, and they're very comfortable using simulation software. They're very interested in doing so. So we end up with a project where people who have the best possible profile to use the software are those who have perhaps the least experience and knowledge. So we have to think about it, and something that we need to think about. The computer equipment, in 2009 we identified, we found people who were interested in working on that. We gave them portable computers, a lot of memory, a lot of capacities. And we're pleased because there are people at SNC for whom it's a passion, who go onto the internet, they bring their laptop home, and it becomes a passion for them, they believe in it. And so I would say that the people who try to make the transition to BIM, they need a computer infrastructure. And during the execution of the project, didn't take time, where we had to modify pretty much all our computer equipment for those who were designing in Revit. So the other major constraint that we had as of 2009, we wanted to undertake small projects to get used to it, except that we had to create our families. There were no families for the manufacturing equipment, for pumps and so on. And that was one of the biggest obstacles that we've had to face in order to practice. I mean, yeah, people need to learn the software, they need to understand design, they have to create their families. I must tell you that that problem will disappear fairly rapidly, in my opinion, because the software does not enable one to have the whole question of intellectual property of what we have. Since you start sharing your plans, people can then have access, and then the staff that you have, in fact, to try to innovate, we say fine, we invest, but fine. I think all companies will have to invest in the same way, and will share the tools that we develop, we'll share that all together. Now, simulation and tools, I must tell you that at present, this is a challenge. With regards to the simulation, what we did, there are people who and we try to have parallel teams in order to, if you need to calculate loads and so on. But at present, in our project at QSIM, the project goes so quickly that we want to make sure that what we are building meets exactly the requirement. So that's pretty much a laboratory of sorts, where we try to use and simulate and use all aspects, but do we use them? The question is, on other projects that we're going to do on the site with BIM in full capacity, the answer is no, it's not the case. On the other hand, we see that there are many possibilities. Potential is there. So the level of clarification of precision, I'll talk about that a little later on in the presentation, speak about the commercial aspects, but how far do you want to go? To what level of precision do you want to go? We mentioned the size of the pipes. Well, same thing. It adds a lot of heaviness in a way, and it can influence greatly the time that it takes to realize and efficiency. So this is something that remains to be defined, that is not quite yet properly defined for most users. So I will let my colleague tell you a little bit more about the implementation, and I'll come back at the end to speak about the market and what it is that we see there as an impact. Well, hello everyone. What we saw so far were the issues from a management standpoint. What I'm going to show you now are the issues from an implementation of BIM on a big project such as the QSIM project, but also the approach that we used in order to implement a new technology, a new philosophy really, on a project of this size. With regard to the BIM implementation, first of all, Revit was used for the architecture, structure, mechanical, electrical, plumbing, almost 100%. We had a team of 130 Revit users, various disciplines, who are still situated on in the project office. So the project office, if you look at lower right, this is the project office. This is where all the users of Revit work. Not all, in fact, because there's a number of these, and we'll look at the organization of the team in a few minutes, who work remotely on the same models on which the on-site team is working. So 130 users, made up of people from SNC Engineering and Architecture. We had 4 firms. IBI Group, there are people here, I think. Revit champions are here. We also have people from Mimaya, HDR, a company, an American company, and Planifico C in terms of equipment design, and BPA, in Parizeau. Okay. So the team was made up of these different elements with regards to the Revit implementation. Now, the issues connected to the implementation. Well, as we mentioned, BIM is a new technology, a new philosophy for SNC Lavalin. Yes, we did try it out in a smaller project before QSIM, but large scope projects with a team of this size is the first project that we undertook. So we need to constantly reinvent how we work. And when I say constantly, well, it's been 2 years that we've been implementing this technology, and yet to this day, we reinvent how we do things. So it's a constant process of improvement, and that means that we must, as the person in charge of implementing a new technology, we need to develop new change management strategy. We spoke earlier on of change management. It is essential to adjust as a function of the needs of the people who are affected by the change. With regards to collaboration, we had the integration of architects who were working within our own office. We had a project office. It's a new culture for us at SNC Lavalin. We're an engineering firm, so that was an issue for the architects as well. It's a new culture to work in an environment that is an engineering firm. We must therefore adjust constantly. There's the virtual team aspect. We've got about 40 people working from different remote offices on the same project. So it's not an FTP file that we're sending here. This is live on our models. And what is critical in this type of situation is to have a good communication plan, to find ways that we'll use to communicate. And also the project office, even if to have such an office is a prerequisite to have an integrated design process, yes, it is still a challenge to have everyone working out of the same office, in spite of the fact that it seems a lot easier, and it is. It's still a challenge. Real-time work, to have all different disciplines working with the latest version and update, directly connected is one of the major issues for people in mechanical, electricity, plumbing, architects, for everyone. Every discipline depends on the others. For example, in structure, architects rely on the model that's done in structure, because what appears is not a redone version of the structural model. It is the model.
Therefore, every discipline depends one on the other. So if there's a major cooperation, so that cooperation takes place. Finally, there's sharing the information. Daniel mentioned value. That was an important part of his presentation. The added value was an essential idea. All of the value that's added to the model has to reach the various players, those who build the project, but also the clients, but the clients also benefit. So project management, the CUSUM project is a project, but our approach is to see the implementation of the BIM as a project per se. To implement this project, we have to plan and organize and have the tools to implement a new technology. So what we did, we set up a BIM plan. A BIM plan is a living document that's constantly updated, that contains firstly the modelization strategy. The modelization strategy, as we'll see in detail, the models will be divided so that the teams can work effectively within the project. We will define exactly who is part of the modelization team, who will be involved in the modelization, what are the various roles and responsibilities. We'll also detail the procedures for the modelization, the standards and the terminology and numbering will also be identified. There'll be the management of the project, the level of detail, the accuracy. This type of questions will really be raised initially and will be clarified in the document. Finally, the integration strategy. If we can do flash detection, we want to use the numbering process as we saw this afternoon, so that this will be defined as in an integration strategy. A cooperation and communication plan is also necessary. There's a virtual team on the project, and it's important to have a strategy for communications, because people work at a distance from one another, so that even if no one was working at a distance, cooperation remains essential. So how do we cooperate? what are the basic rules, Revit, for working on the project. So the modelization strategy, we proceeded in 2 steps. So the structure or division of the project, the models were divided into blocks. We saw 5 blocks at the beginning. In fact, there are more than 5, but we divided the project into different blocks. And the second phase was to assess the level of complexity of the project and divide it into sub-disciplines. Architecture is a discipline that's critical, for instance, for hospital projects. So a mega hospital such as the QSAM, it was important to subdivide so that, one, the various teams could work within these blocks effectively, but because we were aware that we were going to have a major architectural team, this allowed various persons to work at the same time on various parts of the project. So there was inside and outside architecture. Usually it's different teams from architectural firms. There were different consultants, different groups within the architecture group. So plumbing is other disciplines. There were furnishings. So the various items are indicated. So just to visualize what it gave, at the beginning this is what we had. Therefore, strategy by blocks, a model for each block divided by sub-disciplines. Managing the team. Because we have 130 users on the team, it is essential that all these users be able to easily integrate the team. So what we did, the Revit is we use an organizational chart, and we see the team as a whole. All of the Revit users are on this chart. We see the various leaders, team leaders, the Revit champions. The Revit leaders of each consultant are indicated. We also add the roles and responsibilities of each person. For instance, my roles and responsibilities are indicated clearly on the chart. We also put the models on this chart, so that way we can see whether there's a problem with the structure model, and I'm new as a Revit user, I have to know who to contact. Also, if there are documents, we talk about the plan. This can be put directly on the chart. And if something is added to Plan B, then it can be done readily. So the team organization, there's a Revit champion for each discipline. We also mentioned the importance of the champion, or the BIM manager, whatever name is given. But someone has to be dedicated full-time to this for this particular function. The champion has to be dedicate 100% of his work time to this. There also has to be specialists. There are 2 specialists for each discipline. One to create families, and another to create specialists for documentation. Architects, because the architectural information that's entered into the models and that are used by other disciplines, there are other roles then that are integrated as well. So what we did was to create a Revit implementation team. The first person is a BIM coordinator. This is not necessarily a user of Revit. It is a person of from the design team, as Pierre mentioned on the project. there's the just as there's construction, there's also the design of the project. So someone is a BIM coordinator, and to have someone from the design team then is to have someone who can manage the scope of the project and the details that are involved and the extent to which we will use modelization. Are certain, we always ask ourselves the question, are we going to use modelization for this particular phase or this particular function, and how far will we go in modelizing? So this person has to be someone who does multidisciplinary coordination. So he has to know the needs, the construction needs. It is this person who will make sure that all the disciplines around the table are working in an integrated manner. The Revit administrator, that was myself. My role then was to do level 2 and 3 support. So we divided the support of the application into 3 levels. Level 1, these are simple problems that don't necessarily necessitate much support, maybe 15 minutes to half an hour. Level 2, problems that are a bit more complicated that the champions cannot deal with and that are escalated to me. Level 3 are procedural problems. So it's the Revit coordinator took care of this type of problem. My role then was to update the BIM plan as well as all of the tools, the control tools that we will deal with later. Occasionally also I would assess teams, train teams, advanced training, lots of coaching. Also create documentation, best practices, procedures, and training. The Revit champion, for each discipline there's a Revit champion who does the level 1 support. He's kind of a team leader within his discipline, and his role is to implement his functionality into the BIM plan. So he also has to put his input. So they feed me in information. So there's lots of trust towards the Revit champions. They're the ones who distribute all of the documentation required for the implementation. So they're responsible for creating the models. The Revit champions have a role, a cooperative role. They're hands-on on the project. They know what the current problems are. They're the ones who will come and tell me of any problems. They will also validate the level of detail that's required for a particular function. I mentioned there were 2 specialists. Specialist in content. His role is to create and to maintain the project families. So creating families is relatively simple. It's the easiest part of the management of the project. What is harder is to make sure that all of these families that were created are used properly. It is this person then who will make sure that there's no content that's downloaded from the internet. We will use the standard family that's used for the project. So this is the person who's responsible. The organization of the families within the model and on the server. The second specialist, the specialist in documentation, is the person who will manage the views and of the sheets. So there are some people in the room here who could certainly testify as to the type of problems or the many views, temporary sheets that exist. So there has to be a cleaning job that has to be done periodically, managing export, CAD exports and imports. There's So this person then makes sure that this export and import phase is done properly. There's also the creation and maintenance of the templates, of the view templates. The templates are powerful within Revit, but we still have many dozens and dozens of temporary templates that were still operational. So these templates ensure standardization. Then there's a parts coordinator for architecture, responsible for implementing the numbering standards and the terminology for the parts, and to synchronize the parts using the Revit Room Manager. This allows to have a more direct link between the information through Revit and this parts database for the project, and then the correction of any mistakes relating to the parts. So this is the person who makes sure that it is corrected. So the Revit team, there are 94 users. This was at the height of the project. Today there are fewer people. 50 are on site. Others work at a distance. The various places where they work are indicated: Atlanta, Omaha, San Francisco, etc. Communication is critical. Structure, 11 persons, ventilation, 13 users, electricity, 5, plumbing, 10, a total of 133 users. So there's more and more people on the mechanical and electrical side because that's currently where things are happening. So I spoke to you about the Revit organizational chart. This is what it looks like. So this is the full Revit team. So imagine you're a new Revit user and you're told you're going to work on this project. And it can be frightening initially, but on this charter, you'll have all of the information that could take you 6 months to assimilate. You can easily see who are the project leaders, who to speak to when there's a problem. For management tools, I have 5 minutes, I'll be okay. So tools, a weekly BIM meeting. And the objective of this meeting is strictly to talk about the implementation of the BIM. What are the current problems? What actions have to be taken? So there's a coordinator, there's an administrator. The BIM plan has to be updated as you go along. So the tools. So the model progression matrix is another tool. So this matrix is an Excel file that allows to identify the status. Other information in this matrix is the size of the model. This is the information that's put into the Revit. It is important that it be controlled. There has to be a certain number of warnings in the model. So this is what a matrix looks like. The final tool, an issue log, a Revit issue log. This is a tool that's used during our weekly BIM meeting. Every week we go through every problem that is documented. There's a person who is responsible. There's a date. There's the actions that have been taken to resolve a given problem. And what is important for us who are implementing new technology is that it allows us to use all of the problems that we've had on the project to document things that we have learned, the lessons learned, and therefore be able to have new projects by looking at these projects and making sure that we don't repeat them. So this is what the issue log looks like. Maybe we can discuss briefly the impact on future work. Firstly, our work methods. Work methods, then, it's certain that we have a group of experts. We have a project team. There establish processes and a team, but in terms of the execution of our project on a daily basis, all of the projects that we execute, it's the people who implement BIM within the organization. It's not only the use of a new tool, it's really also a complete change, a deep change in the way people work. This is one of the major problems we have is at the level of our personnel. We have to train the end users. There's an important gap between experience, skills, and the user profile. So there has to be a certain passion. Working with other professionals, when there's a new project, a major project, you can already establish foundations. There's an established process. Many projects we have, we will add capacity to the generators. We will change the cooling systems. We will make electromechanical changes within the existing infrastructures. How do we work? Often clients in certain institutions, they also already have projects on CAD. So how can we integrate all of this? We want to go from we want to be able to do this on a day-to-day basis. These projects and even our partners, the other consultants who work with us, don't necessarily know how to use these instruments, and there's also deadlines. So use the tool then to its full potential. This is something that we'll have to work on a lot. There's also other things, simulations, clash detection. There's a lot of work at that level. There's also information management with the clients and the entrepreneurs. And the CUSM project doesn't necessarily relate to the use of the BIM, but the authentication of the engineering data is done electronically. So this is already a change in the way we do things. This is the point we've reached in the use of BIM. So how will we make this transition? We're preparing the plans, and when preparing the plans and specifications, we don't see the level of detail that the software would allow us to see. And part of the responsibility for the coordination is part of the contractor's work. So if we do the initial design, then subsequently with the builder, what will happen if there are conflicts regarding coordination? So these are things that will influence our general way of working and the general execution of the project. And so for the work givers, one of the points, the demand is growing. There are many major projects. One of the worrisome problems or points is that certain work givers don't necessarily have the team to be able to use this software. They're not familiar either with the capacity. For example, what will be the impact on their project? What will be the level of detail that will be needed? So if contractually we ask for the preparation of plans and specifications and your software doesn't allow you to go to a given level of detail, when we hand over the model at the end, where will our responsibility stop and the work givers start? The other thing, realizing a BIM project is also an integrated process. At the present time, in executing these BIM projects, we want to have competitive prices, so some consultants or certain disciplines will wait for another discipline to move forward and make certain decisions, and then this other discipline will go ahead only after. So that's pretty well what I had to say. So this is what we wanted to explain to you and present to you.